Representing data, example 8. This is another histograms question presented in a slightly different way. We've got a variable x, 40 observations are given in the table below. We've got the bar 10 to 15, 16 to 18 and 19 to something which we don't know. Just before we start, I'm going to put the class boundaries on here just so that we're clear on it. You can see there's a gap here between 15 and 16, so the actual boundary there is 15.5. And because we've gone half up at the top, we would go half down at the bottom. So the boundary there is 9.5. Here, 18 to 19, 18.5. So we'll need to know those later. A histogram has apparently been drawn, and the bar representing the 10 to 15 class has a width of 2 and a height of 5. Now let's have a think about that. I'm going to draw a little picture. Imagine this is 10 to 15, the bar representing 10 to 15. The actual boundaries, like we've just said, are 9.5 and 15.5. And so the actual width here is 6 units, and that's represented by 2 centimetres. Vertically, we plot the frequency density. Now, the frequency density is given by the frequency divided by the class width. So for this first one, our frequency is 15, and the class width, as we've just said, is 6. 15 divided by 6 is 2.5. So the frequency density up the side, frequency density is 2.5, and that is represented in this question by 5 centimetres. So that's just giving us a little bit of an overview as to what's going on. It's now asking us to look at the 16 to 18 bar. So I'll draw a little picture of that. We know it goes from 15.5 to 18.5, and if we quickly work out the frequency density, we can see the frequency is 9, the class width is 3, because we're going from 15.5 to 18.5. 9 divided by 3 is 3. So up the side, if we were drawing this on a graph, the frequency density would be 3. So we've got a little puzzle to solve. It says for the 16 to 18 class, find the width of the bar. So if we have a look at the top, 9.5 to 15.5 was 6 units, and that's represented by 2 centimetres. 15.5 to 18.5 is 3 units. Well, if 6 units is 2 centimetres, 3 units would be 1 centimetre wide. So the actual width would be 1 centimetre. It's going to be half the width of that one. So my diagram isn't really very to scale. Let's have a look at the heights. Well, if a frequency density of 2.5 is drawn with a height of 5, then a frequency density of 3 would be drawn with a height of 6. It's just been doubled. So the height of the second bar is 6 centimetres. So by just drawing little pictures and working out what scale factor is going on, you can work out the dimensions of the bars.